viewers, in this video I would like to discuss two examples of Newton Raphson method, example 1 and 2. The example is, using Newton Raphson method, find a root of the equation x square minus sin x minus 2 is equal to 0. Correct up to 5 decimal places. Fx is x square minus sin x minus 2, which is equal to 0. Now let's use the concept of bisection method and find an interval in which root lies. We take random values of x and put in the function. So let's take x is equal to 1 and see that function value is negative here. We take x is equal to 2 and function value is positive here. It means we found one interval 1, 2 in which root lies. Now let's take midpoint of the interval, which is 1.5 as x0, that is initial point or initial approximation of the root, and we use the nth iteration Newton-Raphson formula, which is xn plus 1 is equal to xn minus fxn upon f dash xn. We substitute values on right hand side, and so we see xn minus, here we put fxn, it means function value at xn. So xn square minus sin xn minus 2 upon derivative of function. Derivative is 2x minus cos x. So we put 2xn minus cos xn. Now we simplify it with the help of 1.2 because n is 0 and n plus 1 becomes 1. So x1 is equal to x0 minus x0 square minus sin x0 minus 2 upon 2x0 minus cos x0. We take x0 1.5 and substitute in this value or expression. So we get after calculation x1 as 1.75511819. Now we will go for second iteration, that is n is equal to 1 and we will obtain x2, that is next better approximation of the root. So same as x3, both of them are same up to 7 decimal places. Now we go to next example. In this example, we have to find a root of the equation 5x minus cos x minus 1 is equal to 0, correct up to 5 decimal places. Here fx is equal to 5x minus cos x minus 1 is equal to 0, and we find out one interval by putting x is equal to 0 and 1, and we see function value is negative and positive here. So in between we take any value between 0 and 1, mid value 0.5 or 0.4 or 0.6. So we can take any value as an initial point. Here we take x0 as 0.3 as initial guess of the root, and we see that Newton-Raphson method's nth formula is xn plus 1 is equal to xn minus fxn upon f dash xn. Now we substitute n is equal to 0 and get this value by putting the xn, fxn and f dash xn here. The denominator is derivative of the function. Now we put x0 in this as 0.3 and calculate value of x1. So by putting x0 as 0.3 in this, we get value of x1 as 0.3859852. This is the first root or next better approximation of the root. Now we calculate x2 by using x1 and see the value of x2 comes 0.385335. Now we calculate x3 by using x2 and see that both of them, x2 and x3, are same up to 7 decimal places. In the question it was given that calculate the root up to 5 decimal places, correct up to 5 decimal places. So here we got up to 7 decimal places. Our objective has been obtained and this is the root value. Thank you.